Okay, so we'll move on to cleavage. And what I want to concentrate really on is cleavage is very often tricky to see in thin section. And that is partly because, particularly when you're coming to thin section petrography as a novice, it's a bit like seeing outcrops or exposures of rocks for the first time. You tend to focus on all the sorts of cracks and joints and funny little kind of irregularities. And as you become more and more experienced, you learn to kind of filter those things out. It's the same in thin section. Thin section minerals often have cracks. Here we've got one that has slightly less cracks, but it still has some cracks. In plain polarized light here, you can see those quite clearly. And cracks often stand out much better than cleavage, unfortunately, so they tend to draw the eye to them. And they tend to stand out very much in the same way that grain boundaries do, so they look very sort of similar, boldness, if you like, to grain boundaries. But the thing about cracks is that they tend to be irregular. They tend to, very often, they tend to curve, particularly in minerals like olivine, and here in the pyroxene they're curving as well. So the key thing with looking for cleavage traces in minerals is to look for straight lines, because they should be straight, and parallel lines as well, so sets of parallel lines. And very often they look finer, not always, but very often they look finer than any cracks there are in the mineral. So that's the key, really. The other thing about cracks is that they very often focus alteration along them, because fluids tend to migrate into cracks. They run along them as exploiting them as planes of weakness. And so where you get fluids in crystals, you often get alteration. So that's another useful diagnostic for picking out cracks as opposed to cleavage. So in this mineral here, on the left-hand panel, the plain polarized light panel, you can see that these lines are so faint and so fine that it really is almost more a suggestion, like the grain in wood. So those are those slanting lines running from kind of northwest to southeast across that crystal. And then maybe this is a twin, or it might be just two crystals stuck together. It looks, if you look in the cross-polarized light view, then you can see that there are two very different orientation crystals. And so, lo and behold, in that lower crystal, the cleavage lines run more or less north-south at very different orientation. But they're very, very discontinuous. So you only really see very faint and very short lengths of them. So let's have a bit of a go at this. We've got three different views here. Let's start off with the one on the left-hand side. This is a hornblendite, and I hope everyone can see that you've got grain boundaries in here between the different minerals. So you've got a higher relief mineral down here, which is garnet, I think. But most of the section is taken up with a mineral in varying shades of brown. And I hope that you can see there are some lines in that mineral, and up in the top crystal here there are straight lines running down like that, and some of the crystal sections even have two sets of lines. So are those lines, are they cracks or are they cleavage? So these are a cleavage. They're very clear cleavage in this case. So these parallel lines up in the top large crystal up here, those again are fine lines. They're all parallel to each other. In the other sections, the smaller sections here, where you've got two sets of lines, and those are mostly cleavage, so running like this in this one here, northeast, south, southwest, and then a couple or two or three lines which are running at about 120 degrees to that, across the crystal, more or less horizontally across the crystal. So in these ones here, these sections here, in the middle of that view, you've got two or three sections of the hornblende, which shows the very typical amphibole basal cleavage, so two sets of cleavage planes. Let's move on to this one, to the garnet. What do we have here? Do we have cracks or do we have cleavage? So, and the reason we only have cracks, and we know that there are only cracks in here, is that garnet very rarely, if ever, shows cleavage. So you only ever really see cracks. It's a bit like olivine. There's no visible cleavage in garnet, and so you do tend to see just cracks running across the crystal. And you've also got some areas of inclusions here as well, the sort of dusky inclusions. And then down the bottom, we have olivine. Are those cracks or are they cleavage? So yeah, brickwork cleavage. These are cracks, and so you can see that some of them are curving. Some of them here are quite straight. They're relatively straight cracks running across the middle. So there is kind of some sort of suggestion of that brickwork cleavage that I think you've been shown perhaps in kyanite. You might have seen in kyanite, which does look somewhat like that. But in this case, no, these are actually cracks, and the reason we know that is because olivine has no cleavage. So you will only ever see cracks in olivine. The other thing to remember about cleavage is that when you're looking at your diagnostic charts, the mineral ID chart, for example, it will tell you confidently that amphibole has 2 cleavages, and pyroxene has 2 cleavages, and kyanite has 2 cleavages, and so on and so forth. But not every section of the mineral will show both of those. So some of them, over on the left-hand side here, you can see some of these do have 2 sets of cleavages intersecting, in this case, at about 120 degrees or so. And those are the 2 sets of cleavages in amphibole. But you only see those in basal sections of the amphibole prism. And most of the sections in amphiboles, in a rock with amphiboles, are cut along the prism, sort of parallel to the prism length. And most of those sections then will just show a single cleavage running parallel to the length of the crystal. And most of the rest of the grains in this view here show exactly that. It may be that in some rocks you never see a basal section. And the reason for that is, in particularly metamorphic rocks, of course, you have alignment of minerals. And if that alignment is very, very strong, and you cut your thin section parallel to the long axes of all those grains which are lined up, then you will almost never see a basal cleavage. So this one here that I've just pointed out, that has basal cleavage, yeah. And in fact, another way of telling this with amphibole, this is a particularly helpful amphibole crystal, is because it actually has an almost perfect basal section shape. It's actually 2 crystals jammed together, I think, or grown together. So this bottom one here shows an almost perfect hexagon. It's a bit wobbly and blurred over here, but then you can trace the hexagon back up there and across there and down there. So really, really nice. But don't always expect basal sections to look quite so nice. So over on the right-hand side, I've got some 2 views from the same section of kyanite. And the top one has typical kyanite, if you like, where the cleavage is prismatic, so it's only 1 cleavage running the length of the crystal, and it's very, very weak. It's very difficult to see. And in fact, in the grain below it, just to the left and below, that sort of squarish grain, that's even more difficult to see. You only have a few traces of the cleavage there, and a few cracks as well, just to confuse things. But in the bottom one, we've got on to Simon's brickwork, and this is the kind of brickwork, classic brickwork kyanite. But even there, it's not really playing ball. It's a pretty horrible skeletal kind of scattered mineral. This is probably 1 crystal, all 1 crystal, and probably in the same orientation, but it's just intergrown with the quartz in a very odd, complex way. So there you can see, though, the 2 cleavages. 1 cleavage running sort of northeast to southwest is very, very strong. And then in some of those bits, you've got some cross cracks, almost they look like, but that is the second set of cleavage planes cutting across from the northwest to the southeast. And those look less well defined, and the reason for that is that cleavage in kyanite is not as perfect cleavage as the other cleavage planes, set of cleavage planes. And that's quite common as well, that if you have 2 sets of cleavage, they're not necessarily always going to be perfect. One is very often slightly better than the other.